Hi everyone, it's Mrs. Suter again, and today we're going to do a lesson when we're talking about geology. Now, geology is the study of Earth. Geo means Earth, ology means study of, so geology is the study of Earth. Now, when we talk about the study of Earth, it means lots of things. It means the study of rocks, the study of soil, the study of fossils, the study of volcanoes. There's so much involved in geology. But today what we're going to be talking about is we're going to talk a little bit about rocks and rock formation, and we're also going to talk about fossils. So today in geology, that's what we're going to be discussing is rock samples and fossils. Okay, so we're going to start off and we're going to do our activity first. And our activity is called candy core samples. Okay, and this is very much like what a geologist would do with the Earth, but we're going to take a look at it with candy bars. And then from there, we can discuss how geologists use the same kind of information. So I'm going to be using 3 different kinds of candy bars. I picked these specifically because they work really well for this activity. One is I'm going to use a little fun size 3 Musketeer. The second one is I'm going to use a little fun size Milky Way. And the last one I'm going to use is a fun size Snicker. But my fun size Snicker is a little smaller, so I'm going to be actually using 2 of these so that I can do my project. So I'm getting out all of my little candy bars, my 2 little teeny Snickers, my 1 3 Musketeer, 1 Milky Way. I've got a plate that I'm going to be using to do my core sampling on, and I have some straws. Okay, clear straws work the best, so these are the ones that I like from your cafeteria, so I'm going to unwrap them. So I have some clear straws. Clear straw works the best because we can see through them, and that's what we need to do for this activity. All right, so I'm going to start off with my candy bars. I'm going to start off with my 3 Musketeer first. Now, one thing about this activity is it's better if your candy bars are not hard, like not cold. So what I do is I put them in my hand for a couple minutes to warm them up. I don't want them completely mushy, but if they're really cold, they get really hard, and it's hard to, because our straws bend easily, it's hard to get the straw through there. So that is what we're going to do first. So we're just going to warm up my 3 Musketeer. Okay, I am going to open up my 3 Musketeer, and I'm going to keep it on my plate, the wrapper. That way I can remember which candy bar I'm working with. So here's my 3 Musketeer. Now, I'm going to take my straw, and I'm going to put this down so you can see. Okay, I'm going to take my straw, and I'm going to put it into my 3 Musketeer. Now notice that sometimes I have to kind of wiggle it a little bit to get it down into that 3 Musketeer. Now, I want it to go all the way through. Okay, so that means it has to come out through the bottom like that. Okay, now I don't want this extra stuff on the edge there, so I'm going to take that off, and now I'm going to pull it through, and you can see that I have a hole clean through my 3 Musketeer, and I have my sample inside my straw. Okay, so this is my first candy core sample. And if I look at my sample very closely, I can see that I have this really dark top up here, which is that chocolate. Then I have some light, fluffier stuff in the middle, and then I have the dark, harder outside. Okay, so this one has what we'd say 3 layers. It has a layer of the dark chocolate at the top. It has a layer of the fluffy nougat in the middle, and it has a layer of the chocolate on the bottom. Now, I want to keep this core sample, so what I'm going to do is I'm just going to snip my straw, so I have just the core sample, and I'm going to save it by putting it right with my wrapper so that I can remember that this core sample goes with my 3 Musketeer. Okay? Now, you can either get another straw Or I'm going to continue to use this one since it's still big enough, and I'm going to do my next candy core sample. So I'm going to use my Milky Way. Again, I'm going to put it in my hands so that I can warm it up a little bit. Makes it easier if it's a little warmer. As you see, it's not super duper easy to get my straw through there, but it is possible to do that. So I'm just kind of warming up my my Milky Way. And then I'm going to peel my Milky Way, and then here's my Milky Way bar. And again, I'm saving my wrapper so that I can remember which candy bar I'm working on and what core sample it is. So now, again, I move my Three Musketeer over to the side because I've got it done. Move it over there, clean off my plate. Oh. And now I'm going to do the same thing with my Milky Way. See if we can take a look at my Milky Way there. Here we go. All right, now I'm going to go ahead and start drilling in. And again, you see that I'm kind of wiggling a little bit and pushing down through. Like we said, it's easier if your candy bar is not really hard. So I got to push down. Now I want it to come all the way through and out the bottom. And there we go. Okay, so now I've got a hole right through my Milky Way, and now I've got my core sample. Okay, so I'm going to take a look at this core sample. Now this core sample looks a little different. Okay, it has that thick chocolate at the top, then it looks like it has a little nougat, but then it looks like it has caramel in the middle there. Looks like, excuse me, a little more nougat, and then that chocolate layer at the end. So this one has some more layers because it has the chocolate, then it looks like caramel, then it looks like nougat, and then it has the chocolate again. So I can see that this one has a little different layers than my Three Musketeer. Okay, so again, I'm going to cut this one, and I'm going to lay it with my Milky Way paper and my Milky Way so that I can remember that this core sample was from my Milky Way. Okay, now again, if you want to use another straw, you can. I'm going to continue to use this one because I've still got quite a bit of it left. And I am going to warm up my Snickers. Now I know, because Snickers is one of my favorite candies, that they have peanuts inside. Okay, so this one might be a little bit harder to get the straw through, especially if you've hit a peanut, because peanuts are pretty hard. So here's my Snickers. I'm going to keep my paper. Okay, put my Snickers on my plate, and then again I'm going to do the same thing and take the other core sample of my Snickers. Okay, so here's my Snicker, and I'm going to and I can tell you right now that it is a little easier if I do this kind of on a side, because I might not hit a peanut. You can see that this one is kind of hard to get my straw through. Oh, there it goes. And my straw wants to bend a little bit. But again, I want to go straight through it. Nope, that one doesn't seem to be working so good. Let me go on this end. And there we go. And I want to go straight out the bottom. All right, now there's my candy core sample for my Snickers. And you can see that it has the chocolate at the top. It has some clear, lighter nougat, and then it has some caramel, some very light, looks like nougat again, some kind of thing like that, and then the dark chocolate at the base. So it looks like its layers are quite a bit different. It has a lot more of that nougat. Oh, I see a little bit of peanut right in there. Okay, so there's my core sample for my Snickers. Now, I have my 3 core samples. So I'm going to put them each with their wrapper. So I've got my Snickers. Okay, I've got my Milky Way over here. And I have my Three Musketeer. Okay, so all of my core samples are ready to go. Okay, so I've got them on my plate here so then I can look at them. All right, so now I want to share with you a little bit of my presentation so that we can talk about these things. All right, so we already took the candy core samples from all of our candy, and so now we're going to answer a question. Are individual layers visible in your candy core sample? Well, as I'm looking at my candy core layers, I can see there's chocolate, nougat, chocolate. I know this one's the Three Musketeer because if I remember correctly with that one, and I have it on my paper. So yeah, I see layers. So I'm going to type down here, yes, layers are visible. Okay, observe and describe the layers. So I'm going to say Three Musketeer has only 3 layers. 2 of the chocolate, and the middle is a lighter nougat. Okay, Milky Way. I'm going to take a look at it again. Let's take a look at my Milky Way. Sorry, my phone is ringing. Okay, now my Milky Way, it has 1, 2, 3, 4 layers. It has 4 layers. So it looks like chocolate, caramel, nougat, and chocolate. Okay, so I'm going to say the Milky Way has 4 layers. It has 2 of the chocolate, and 1 of caramel, and 1 of nougat. Okay, now it's time for me to look at my Snickers. So I got my Snicker one out. Okay, my Snicker one has 1, 2, 3, 4. Okay, so again, the Snickers has 4 layers. It has 2 chocolate, 1 nougat, and 1 caramel, but the nougat is a lighter color. It almost looks white-ish in a way, not as much brown. Okay, so there I have my my answer to my question. All right, now let's go to the next one. So we already did the other ones, and we already talked about how they're the same and different. Now, another fun activity you can do is you can have a friend or a family member take one of your candy bars and not tell you which one it is. Go take a candy core sample of it, bring this core sample back to you, and let's see if you can identify which candy bar it came from looking at your candy core samples to the mystery one to see if you can figure out which candy bar it is. Okay? So that is an idea about taking core samples. We're looking at layers, we're looking at colors, we're looking at how thick the layers are, because truly that is what geologists do, some geologists. So you can see over here that these are actual core samples, okay? And just like rocks, our candy bars have the many different ingredients like caramel and chocolate and nougat, and our Snickers had some peanuts in it. When I take that cylindrical core sample using the straw, I can see all the layers. And when I put those candy core samples side by side, I can tell that the samples are different from one another. The layers are different thicknesses, different colors, different ways that they were put together. So this is how geologists figure out information about the Earth. They take core samples. Okay, so I have from some geologist friends of mine these are bags of core samples they've taken from different places around West Virginia. So when I pull one out, this is actually a core sample of rock from the earth. Okay, and now I can see layers. I can see little fragments of different rocks and different pieces. Okay, let's see if I've got another one here that's a little different. Okay, different place in West Virginia. Here you can see the layers showing up really clearly. All the layers, light and dark. Notice that it's really dark up here, very thick, and then light, and then dark, and then light. You can see that it has lots of different layers to it. Okay. Let me see what else I have in my bag today. And here's a different one. And you can see very clearly the layers on it as well, dark and light. Now, these layers tell a lot about the history of our Earth, okay? And we're going to talk about how these layers, how these core samples do just that. So, let's take a look back at where we were. So, here you can see one of the ends of those core samples that geologists drill. And when they examine these core samples, they're looking to tell different types of rock and different types of minerals so they can tell a little bit about Earth's history. So down here, this little dark piece, this is a piece, it's called a lithic fragment, which means it is from lava. And lava leaves different lithic fragments. You can see right here we have some lithic fragments from lava. So we know that this sample was taken from an area that at one point in time had to have been near or close to a volcano because it has lava lithic fragments right in the core sample. So we know that this had to have been an area where lava actually flowed down and became hard like a rock. Now over here you see lime class. These are the white specks. Now relic lime class come from like seashells. Seashells have a lot of lime in them. And so when you have those right here, you can see that there must have been water here at some point because the seashells have that lime in them. So I have those. Then I also have some pumice clast right here, and these darker. Now pumice is also formed from lava that cools very, very fast, and it leaves a lot of air holes in it. So we know that if lava flows down the volcano and it goes into water, it's going to cool very fast, and that's what's going to make that pumice, the pumice clast that you see inside the rock. So I can tell a lot from the area by looking at this rock sample. I can tell that it was near volcanic activities, and I can also tell that it had to have been in water. So maybe there was a lake that was very close to a volcano, and that the water and the ash and the lava and the ash flowed into that lake or that body of water, and that created the cast that we have here. And the lime tells us that there had to have been a bigger body of water in order for things to be living in it. And then we have the pumice, so we know that the lava must have flowed in and cooled very quickly. So this can tell us a lot of different information. So geologists can read a rock core sample like you would read a page of a book. They can look at each layer, and it records a period of time in our history. So a light colored layer of rock that's about 60 meters below the surface would be showing you a massive eruption. So we'll leave this white ash behind. And that ash, once it's laying on the ground, when it rains, it'll wash that ash down into maybe a lake, body of water, where it settles down to the bottom. And then it creates this sedimentary silt at the bottom. Then, if you get more layers and layers of sedimentary mud on top of that, it'll form a whitish layer in the rock. So I'm looking for that to see if there's a really light layer, then I know that I have some volcanic ash that must have gotten pushed down into some water at some point, or a big lake. Okay, now if I see further up in the core sample that there's some dark, which in this one I have, this is some basalt rock right in here. And volcanoes, when they erupt, this is the type of rock that they put off. So scientists can see that many layers of the dark material tells me how frequently that volcano must have erupted and how far back in the past. So this gives me clues about when the volcano last erupted and may help me predict when that might erupt again. So they're looking for the rocks to tell us the story. Now, we also use rock core samples not just on Earth, but also on other planets. Right now, up on the Mars, we have NASA has launched a rover. It's called the Mars 2020 Perseverance rover. And the job of this rover is to also collect core samples and rock samples from Mars so we can analyze them and tell the history of Mars and what kind of minerals are on the surface of Mars. So here's a video I want you to see that is going to show you your core sample, or how we look at the rover and what the rover is doing. Sorry about my phone, it just keeps ringing today. I'm not sure what's going on with that. So let me see if I can show you that. Okay, let's look here. And now you're going to be able to see this Mars rover. Okay, here we go. It doesn't have any sound, but here's what Perseverance looks like. And here you can see, well, I guess it has a little bit of sound. Okay, now this is going to be its drill. It's going to pull the drill out, and it's going to make that drill down into the surface of Mars to take that rock sample, that core sample that we were just talking about. So here you can see it's drilling in. This is down below the surface, what it looks like. Now it's kind of hollow on the inside, so it's pulling out that sample, that core, like I just showed you. Now it's putting it in its analyzer. It's going to analyze that rock core sample and store it for later. So if we need to gather it later or do some more testing with it. So it's going to go into its little mobile lab here. It's going to be inserted into the chemical analyzer or the mineral analyzer, same kind of thing. So here it goes into that. Now it's analyzing and it's sending data back to NASA, like what was in the sample tube, what was the image look like, how heavy was it, and then it's going to move the sample into storage in case later on we need to do some other experiments with that rock. So here's where it's going to store the samples of the different rock that it's taking. Now it's going to travel to another part of Mars. It's going to take another core sample and it's going to keep analyzing and sending that information back to NASA. So as you can see here, it was launched February the 6th of 2020, and we are watching it to see what kind of information we're getting back. Okay. Now there was a period of time when the Mars rover actually, the drill got stuck in the Earth, and it was stuck and we could not get it out. So we're hoping that things are going well now. Okay, so engineers, there's lots of engineers who take core samples and to tell lots of things about rocks, and they're called geotechnical engineers. And they're looking at the geological formation of rocks and sediments because they're looking for coal, oil, natural gas, and precious metals. So right now, especially in West Virginia, they've been doing a lot of this because they're looking for a particular type of rock called Marcellus shale. And under Marcellus shale, they're finding natural gas. So they're looking for that kind of rock so they can tell if there's natural gas. And right now, we've been pretty lucky to be getting a lot of natural gas from our area, which is why you see a lot of those drilling trucks coming by. In the past, we did a lot of the core sampling looking for coal. We also do core sampling for oil, not around here, but in other parts of the United States and other countries we do that. And we're also looking for precious metals that we can use for building, iron to make steel, those kinds of things. But scientists also take core samples from what we call permafrost, which would be like up in the Arctic or Antarctic. They're taking core samples of the ice sheets so we can measure climate change over time. So that's another thing that geologists do. Now, this is a picture right here of the largest core sample that has ever been taken. And this particular one was taken 7.5 miles into the earth. Okay, and this little area is called the Kola Super Deep Borehole, and it's in Russia. These are roads, if that tells you how big these holes are. So they drilled down 7.5 miles into the earth. Now, since the Earth's crust is only about between 5 and 10 miles deep, we know that this is as far as we've gotten to drill so far. So we're looking at the movement of the rock. We're looking at what kind of rocks we get further down as we get deeper into the Earth's surface. Okay. Now, we do a lot of core sampling around because we're also looking for construction buildings. So whenever we're going to build a new building, especially a skyscraper, big office building, we're going to do core samples into the ground to see what the ground is like, because certain ground doesn't have the strength, the rocks and the soil, to hold a very heavy building. Buildings are incredibly heavy. So we're always doing, excuse me, we're always having geologists go out, take core samples to find out what kind of rocks under there, what kind of soil, what kind of water, and how compacted it is, so that we know that if the earth has enough structure and support to hold a building of this amount of weight. We're also looking for contamination, if there's any water or soil contamination below the site, because we would have to address that before we were able to build. Now, the other thing that we as geologists look for is we also look at fossils. Fossils also tell us about the Earth's past. We're looking at the plants and animals that used to live in our area at a certain period of time. Now, fossils are impressions or remains of impressions left by plants and animals that lived millions of years ago. So right here you can see we have a leaf. This looks like a fern or fern prod, and it's embedded in this rock and it left its impression. So we can tell a lot about what the area was like by what kind of plants and animal fossils we find here. So we would know that back in a million years from today, this area must have had some type of forest, because that's where ferns like to grow the best. So what we're going to do is we're going to take a look at the site called Fossils for Kids. This is a great site, and all you have to do is hit or go to fossilsforkids.com. And we're going to look at some fossils, and we're going to look at things about in our area. So right now I'm going to go to Now and Then. And these are some of the really great fossils that these fossil hunters have been able to find. What I'd like you to do here is I'd like you to pick one that really intrigues you and you want to learn more about it. I want you to click on it. So for me, I'm really interested in this one. Looks pretty neat, so I'm going to click on it. Now this tells me it's fossil coral. Here's the coral. But back then, this is what it would have looked like. It's called a horn coral. And the coral actually has this living animal, and this is its shell. So that's what got left behind, was the shell, and it became a fossil. Okay? Now, I can go and look at another one. Ooh, I wonder what this is. Oh, now this tells me this was a whale tooth. And here was the prehistoric sperm whale, a picture of what it would have looked like when it was living. And it says it was past 20 million years old. And so it tells you a little bit about what it ate and a little bit about how it was important in the habitat at that time. Okay. Now I know one that everybody really loves is looking at this one. Okay, this one right here is a large shark tooth. And it actually came from the megalodon. And it tells you down here that the megalodon was 50 feet long, and each of its teeth were 6 inches long. So if you think about a ruler, I'm looking at my 6-inch ruler here, that tooth would have been that long. Now, I know I wouldn't have wanted to get eaten by that. And the megalodon ate things like whales and sea lions, so it tells you a little bit about it. So when you get some time, come onto the site and look at some of the neat fossils and learn a little bit about the different fossils that we have that have been found. Okay, the other thing I like is going into this part right here that says amber. Now, amber often traps animals, insects from long, long ago. And this reminds me of the movie Jurassic Park, because in the movie Jurassic Park, they grabbed some DNA from the dinosaurs from a mosquito that was trapped in amber, and they were able to drill into it, grab out some of the blood from the mosquito, and then create the DNA sample. Now, I'm going to be talking a little bit about how you would do that in another lesson called DNA, and so I hope that you'll tune in for that one. But how this happens is insects land on a tree. The sap from the tree slowly comes down and covers up that insect, and then it gets trapped in there. And over time, that sap, or tree resin, we call it, forms into a rock, and that rock is what we call amber. And now that that animal's trapped in there, it doesn't decay. So you can see down here, these are other animals or insects that have been trapped in that tree resin, and these are what we can see through the amber today. So I think this is very interesting, and if you like the movie Jurassic Park, this one will be interesting for you to look at. Now, if you come over here to the one that says Sands of Time, Sands of Time, I really like this because this one shows me the ages and the time periods. So this is the most current time, actually not today, but about 1 million years ago. Down here is the oldest. This is like 600 million years ago. Okay, so if I look up, these are the different periods. So here's the eras. So this is called the Paleozoic era, the Mesozoic era, and then up here as we get closer to now, we see the Cenozoic period. Then, or era. Then we get into the periods. This is the time period of about 30 to 40 years that these animals lived, 30 to 40 million years. So if we look at this, you can see that I had mostly down here coral, water animals, very small water-type animals with shells. When I go up here a little further, here you can see it looks kind of like a crocodile. I have a mosquito. Now, if I go up a little bit further, I don't get the dinosaurs until about right here. This is the Triassic period. And here you can see some of the dinosaurs emerging. Then in the Jurassic period, that's when you see those ones that you would see in Jurassic Park, some of these dinosaurs appearing. But if I go older than the Jurassic period to the Triassic, and then I go down one more to the Permian, look at this animal right here. What does that look like? Well, that's right, that is a frog or a toad. So to think back to there, frogs and toads have been around longer than dinosaurs. That's amazing to think about. Mosquitoes have been around longer than dinosaurs. So these are some animals that have really stood the test of time. Okay, then up here we get to more recent animals, and then more recent, this is during the time of what we would call the Ice Age animals, and then up here is where we would be now. Okay, so I just think this is interesting to see what kind of animals lived about what time period. All right, and now the last thing I want to talk to you about is going to this particular one. It says X marks the spot. Now on this one right here, you can go, and we live on the East Coast, so if you go to East Coast sites, you can find where we would find fossils in our area. So, now down here, this is West Virginia, right here. This is Charleston. We live about here, down below Pittsburgh. 6 and 7 are two fossil hunting locations in the state of West Virginia. So if you want to go hunting for fossils, you could click on here. It'll give you a map, tell you where it's at. This is called Lost River Fossil Hunting. It's in Lost River, West Virginia. It'll tell you how to get there, what it looks like. Then you can see the rock formations here. These are people who've collected rocks from there. Tells you exactly how to get there. And then it even showed you what it would look like, where you pull off. But if you go down here, these are some of the different fossils you would find in that area. And of course, if you click on them, it's going to tell you a lot more about the fossils. These are all fossils that were retrieved from that area in West Virginia. Very interesting. Look at all the shells and the coral, trilobites. This tells a lot about our past. These are the kind of animals that lived during that time in that area. And since they're water animals, that would tell us that a long, long time ago, we used to have water in this area, maybe seawater. And if you click on 7, this is going to take you to the other site. It's called the Mahantanago Formation Fossil Hunting. Here you can see some of the fossils that are actually in the rocks themselves. Here's fossils that were gathered from there. This is a shell, you can see. Here are more fossils. Here's another fossil. Whoop. Go back here to the fossils. Whoop. Here's one. Here's one. You can see one here. Here's a close look at the fossil. And then if you go down a little further, you can see the area, the formation. And then it's going to talk a lot about the fossils in the area. So here's a bunch of fossils you would find in that area. So if you ever want to go on a little vacation close to home and collect fossils, here is a good place for you to go. So these are good places for you to look at. And this is under X marks the spot, and it's under East Coast sites. So I just wanted to share that with you so you could learn a little bit more about fossils as well. Okay, so we've explored the now and then and looked at some of the different fossils. Then I wanted you to go to the amber section and look about what creatures were fossilized in amber. Then if you go to the sands of time, we can look about when the different animals were born or were living on the earth, which ones are older, which ones are newer. And then the last one is going to X marks the spot, and looking for some fossil sites in West Virginia. And so if you go do all that, you would learn a lot more about fossils in our area. So once you do that, think about, what do the West Virginia fossils tell us about our past? What is the story that we would gather from West Virginia from the fossils and the rocks we gather from around here? So anyway, that is what geologists do. I hope you do go out and look for some fossils. I hope you have done the candy core experiment with me. And I hope that you understand a little bit more about how rocks tell a story and fossils of the past on our Earth. All right, so that's all for today. I hope you enjoy. In a couple weeks, we'll be talking about DNA and biotechnology. So I hope you're going to be tuning in then. Again, I'm going to be talking about Jurassic Park. So hope to see you then. Enjoy your day. Bye, guys.